Okay, so the meeting is being recorded now, and by continuing to be in this meeting, you are all consenting to be recorded. So thank you and welcome again, to this module 3 webinar and for our data 445 course. And let me go to the next one. I'm going to skip the meeting etiquettes because we're just a small crowd, so I really don't need to, have you kind of go through these rules and then all that. We can just keep it as usual, usual participation from Alex and Yelena, and we'll go with that. Okay, so I'm going to skip this part. And so today's agenda, we'll talk a little bit about big data processing, right? Just once again, add more color to what you've kind of have gone through and during this week, especially in what the last week as well. We'll talk about assignment 3, the most important piece here, and then of course address any questions that you may have at the end. At the same time, Alex, feel free to ask any questions in between. We don't have to wait until the end. Okay, so just a little retrospective before we get into the thick of things here and talk about big data processing and assignment. You did an excellent job with assignment 2, and what I mean by you and Alex, you and your peers, your classmates as well, in an excellent job there. And I would look forward to the same for your assignment 3 as well, which is still within AWS. It seems like I think it appeared to be pretty interesting, and I think I didn't as I said, I expected there could be few folks may stumble or may have issues, but it seems like it worked like a charm and nobody has any issues with the lab whatsoever. So which was very, very good to know that you and your classmates were able to get into AWS and work through the assignment without issues. The discussion postings, well, I wish I could say the same, but it still need to. I'm looking for some more depth and variety, to be honest with you. Not that there were anything. I mean, they were up to the mark, of course. I would say in terms of the questions being addressed or things of that nature. But if you submit it earlier to engage with your classmates, it's just going to be another extra learning for you. I mean, that's what all that discussion is about, right? But if we get the submissions or postings like on a Tuesdays, it kind of defeats the purpose almost, because it's a matter of just kind of putting something out there or asking your classmates a question, which many a times nobody's going to be able to even respond back on a timely manner because it's already late on a Tuesday. So just once again, I'm going to ask you all to kind of get into this as soon as possible and as early as possible, to give your classmates a chance to respond back, you to engage with your classmates as well. Okay. Please submit the midterm course survey. And I sent it out. I sent out a reminder as well. And folks, this is going to be very helpful for me. Trust me. And this is very, very objective. We are going to be looking at. So it's not how Alex kind of responded or how someone else responded. It's about like what kind of what are you seeing, right? It's not basically thinking about like who responded what, but it's going to be very objective. It's anonymous, so there's not even any way for us to kind of capture who did what or what was being responded, but it's basically helping us to see if there's any course correction required or any future improvements required for this course. As you and your classmates know, this is the first time we kind of rolling out this course, and so if there's anything that we can do to make this better, we certainly want to take notes of that and make sure we kind of hear you and listen to you as well. So take advantage of this webinars, and Alex, we're doing a fantastic job on behalf of your classmates. You've been here most times, and I see some of your classmates also taking advantage of the recording. So keep up with that, folks. And these webinars are touch points, my touch points, Yelena's touch points with you. So I hope you kind of take advantage of that. We are here to address your questions. We're here to kind of see if there's any issues or anything on your mind that you want to discuss, right? These sessions are all about that. It's not just one way here of me trying to come up with a presentation and helping you. It's about helping and addressing your questions or whatever you may have in mind to talk about. So I can change my agenda based on what you guys may have in mind. Always keep that in mind. Okay. All right. So with that, and before I kind of, once again, move on to this topic here and go deeper, Alex, do you have any feedback or anything on your mind as far as retrospective of how your last couple of weeks have gone by or the last few weeks have gone by?
No, I think the only thing I'd say, you asked for some feedback on an assignment 2, and I think it was relatively straightforward. You really did paint a pretty clear picture for us on what we're supposed to be doing, and it was helpful in kind of familiarizing ourselves. And it looks like assignment 3 is essentially the same sort of mold, kind of following along with the instructions. It seems like it's going to be a bit trickier with the learning the PySpark, but other than that.
Yes, you're right. You're right. Absolutely right. That's the tricky part there. I think the first part is pretty simple. And it's for something that you go, but you're going to building upon that. You're using in our cluster, a Spark cluster, and using a PySpark notebook, which is going to be tricky. But we'll talk about that. But that's you're right. I mean, that's the part that you want to be careful with, and that's why kind of doing it earlier would be better. As a matter of fact, I would say take advantage of the lab being for you for the and you having such a good, I think you can still go and do it multiple times because you don't get charged as much heavily, or even if you do multiple times, it's going to become second nature, and it's going to really help you with, because some of the things that you're doing, and we'll kind of, I'll show you some of the stuff here today, and see how it's being used in the enterprise world and what you've already accomplished. So sometimes we think that things are more complicated in our workplaces or how it's done in the enterprise world, but it's really not. And we'll address that. So I'm going to hold on. So just hold on to that thought, and we'll kind of come back and talk about it a little more. Okay. So thank you, Alex, for your feedback. Appreciate it.
Yeah, thank you.
So where are we in our journey, right? So you kind of learned about different types of ingestion, right? How do you kind of take in data, right, into and load it, whether it's an S3 bucket, whether you know how to load data into any kind of databases. You've learned that. You've done that before. You've been doing it many more times, and you've done it in this course as well, or in this assignments as well. You learned about some storage management, right? You learned about last module, you learned about all different kinds of storage management, and you probably may have seen the recording of the last webinar where we talked about different types of big data databases that are available and how they are kind of being used in the enterprise world. What you're learning, and this is where we are today, it's about big data processing. Okay, so we got the data in, we kind of have them stored, we know how to store the big data. How do we now process the data, right? So this is the current step of processing that data. And then the last and the final piece is making sense out of the data, right? Doing the analytics on it or doing some visualization on it. That's going to be that entire complete cycle, right? So we are pretty close to that last point there, but right now we have to go over the big data processing part, okay? So let's validate these statements, based on what your learnings have been so far, and especially during the last week and a half. Let's see what you think about these statements, right? Does it make sense at all? Do you agree, disagree, or any other comments that you may have? So the first statement here, using the storage management tools to query and analyze the data is good enough for big data processing. Think and let me know what your comment is on this one, Alex.
I think good enough is a very normative statement in the sense that it isn't really set a good baseline, and storage management tools is a bit vague, but I'm going to go ahead and say no.
Well, close. I would say yes. It depends. Once again, I think you hit to the right one. I think what you were saying in the beginning was absolutely correct. Sometimes It could be, or it may not be, right? Once again, depend on the use case, right? Sometimes, just having an excellent database that does a lot for you, right from ingesting from different data sources to storing different kinds of data to querying and giving you a query tool on the top of it, you may be okay with that, right? I mean, but once again, it depends on the on the use case and the type of data and the type of enterprise that you are, and then the amount of data that you're ingesting, also, right? So yeah, but you're right. I mean, but once again, there's no right or wrong answer. It's also about what's the use case. The next one here, in today's world, we only worry about real-time data processing. Who cares for batch processing these days?
I'm going to go ahead and say that is blatantly not correct. I'm sure there's a lot of, I mean, in the work I'm doing, we're doing a lot of batch processing. We don't have any real-time data.
Very well said. Very well said. Yes, you're so right. And this is true not only for the type of work you're doing, Alex, but even if you look around, and I'm sure you must have done that as well, that a lot of companies still go through batch processing. That has not gone away, right? Look at many financial companies, banks, medical records, and all those insurances and stuff like that. You'll see a lot of batch processing that gets done today. Especially the huge advantage you have with that is that you have task automated, which could be done when it's off peak hours, right? Maybe at night when everybody's gone home and you got to get things done. Well, just with a push of a button or whatever is being scheduled, you get it done. How cool is that, right? All that processing power that could have been wasted when nobody's using it, you are making use of that. So it is still very powerful tool and a very powerful process. So batch processing is still very much relevant today. So very rightly said that. And the last one here, adding more memory to your system can increase the in-memory computation of the data.
Logically, I would say yes, but I think it also depends on your processing capabilities.
Yeah, you're right. But once again, I think with the way we are headed right now, it's we are kind of moving into a zone where companies don't want to, or into a phase where companies don't want to really invest a lot on building infrastructure, right? With a lot of things being going on the cloud, they would rather have something that, it's not just about adding memory, but maybe it's about saying whether you need a change of architecture, whether you need a change of or your processing or the way you process things, and all of that, maybe a shift of that rather than just simply, oh, you need more data has come in, let's add more disk or let's add more memory, right? So yes, you're right in a way that infrastructure, you could add memory, yes, it will certainly help, but there's going to be a cutoff time, right? At a cutoff for how much you could go on investing more and more into your computing power, right? Into your memory power as well for your processing. Maybe it's because maybe you need to think about the design. Maybe you want to think about the architecture. Maybe you want to think about the process that you're following within your company that matters. Okay. So once again, there are no right or wrong answers here. I hope it's about what kind of use case. But I just wanted us to kind of start thinking about it, because you will hear this a lot, and I'm not making this up really. I mean, a lot of these things that I'm kind of bringing up as statements are things that I've heard, things that I've heard people saying or asking and saying, oh, yeah, this is what it is. And these are the statements I'm bringing it up. So you will also probably hear from many folks who, especially knowing that you are, working on this degree and you're having a degree in data science or a certification, well, people would come to you and say, hey, is this true, right? Or is this how it is? And that's when you'll really have to, think through. That's the reason why I'm kind of making us all kind of think through these statements and make sure we understand, right? Okay, all right. So as far as the processing goes, right? So we talked about what different types of processing, and you went through your reading as well. So the first and foremost is batch processing, which doesn't need any introduction. It processes data in small batches, and processing can occur at off-peak hours. So nothing more to add there, right? The other type of processing, stream processing or real-time processing, where you're hearing about data that comes at very, very fast speed and you want to act on it, right? There's data that could be like coming in as messages and like, alerts, like, maybe you're monitoring a system and you've alerts and alarms coming at you at a fast pace or whatever pace that could be, but you want to react at the time you get an alert, you get an alarm, right? You're learning data, you're getting data from all these different IoT devices, right? And you want to react accordingly, right? Based on how, maybe it's a system that's being used within the car, which has to really take care of everything that's going on. You hear about all these auto-driven cars, right? And how do they really kind of work on that? You want to make sure that you're reacting to everything that you see, and it really makes sense out of it in real time, right? So stream processing or real-time processing is the other type of processing that comes into play. So there are systems that work with batch processing, systems that work with stream processing, but then there are systems that have to work with both. Really, they would need some batch processing, that would need stream processing, and that's where hybrid processing came into play, right? Because companies today, especially in today's world, you would say that companies just don't want to just be only thinking about batch processing. They will have to at some point think about stream processing or real-time processing, or maybe they've already started doing that. So hybrid processing is becoming more and more relevant in today's world than ever before, right? And so here, you're processing data both in small batches or in real time, and processing is controlled as required, right? Now, in stream processing, it could be at or at peak or off peak hours, because you have to react as and when the data comes. Here, it depends on whether you're doing things in a batch mode, you're doing things in a real-time mode, so you can control when you want to do, or maybe it's on all the time. You are hearing, listening to the data all the time, right? So but it's how do you achieve that, right? What kind of technologies are out there? Or if there are technologies that take care of batch processing, but they may not be taking really good care, or they may not be really doing very well the stream processing, or there may be technologies that may be really good with stream processing, but or real-time processing, but not with batch processing, right? How do you kind of then work with that, right? So that's why hybrid processing is all about coming up with different architectures. So to kind of make sure that the companies today can do hybrid kind of processing, there are 3 different architectures that are kind of and there are many more coming out, by the way. So just don't stick with 3, because as we speak, and probably after after this, maybe you'll see that there are a lot of research going on for different kinds of architectures that are maybe coming into play pretty soon, right? But the 3 kind of that's most popular today and that's very much relevant, one is the Lambda architecture, and that's something that you may have also heard. But this Lambda architecture, the batch and the real-time data processing, they're kind of packaged together, right? Cool, right? How cool is that, right? You have an architecture that could have a batch mode, that could have a real-time processing mode, and okay, well, the company is it's all set, and they don't have to worry about whether the data coming in and whether they have to do batch processing or real-time processing. Now, then there's another one called Kafka Architecture, and Kafka Architecture has the batch and real-time data are processed, but it is processed through a single channel. Instead of having 2 separate channels processing the data, it said, well, let's have just one channel processing the data. And we'll see why is this Kafka architecture, why did it come into being, right? What is the disadvantage to Lambda of having these two separate channels versus having one channel. And maybe I would have given it away by saying that two channels to a single channel, but we'll see. And then the third one is the Delta architecture, right? Where efficiency is gained by processing the delta or incremental data only, right? So you are focused more on the changes that are coming to the data that is already, that was there at n-1 time, whatever the data that you had, you're going incrementally on the that, right? Plus, you're also kind of going to make use of something called delta lakes here, like an enhanced data lake. So you heard about data lake. Now I'm kind of talking about delta lake. So we'll talk about that soon, right? We'll talk about each of these architectures. So just stay with me here while we go through these three different architectures for hybrid processing. But are you following with me so far? Alex, any questions till this point in time?
I do have a couple questions about this, but it sounds like you're about to answer them. So I'm going to hold them until you go through the different architectures.
Okay, excellent, excellent. Alrighty, we'll look forward to that. So the first and foremost, as I was saying, the Lambda architecture, right? So Lambda architecture is a very simplistic view, by the way, and I love this picture. That's why, because I didn't want to come up with a very complicated picture that you'd see in many articles and journals and things and books. I wanted to come up with a very simple architecture because this is what you want to keep in mind. This is what a Lambda architecture is, not rocket science, right? It has a batch layer to process the batch data. It has a storage component for the master data, which is immutable master data, that everything that kind of flows in is going to be saved in that master data. Even if it flows into real time, it is still going to have pushed that data into a master data set. So there's always going to be a source of truth, a original source of all data that has come in, right? So you have a batch layer that can process all that batch data. This is also the layer which can even build your predictive models, right? You build your machine learning models, right? Because machine learning models will definitely need all that data. So you'll probably make use of all that data that you're ingesting. The next is the other layer is the real-time processing layer, where, once again, very self-explanatory. Any real-time data that is coming in, whether they are messages or whether they are like coming from IoT devices or machine sensors or whatever that is, any kind of, or maybe it's a social media network that, you're getting all these different messages or emails or stuff like that. They're all real-time data that is coming in, which is being processed by your, real-time layer. Now, there are different kinds of serving. There's one serving layer now. Now, there could be one single serving layer, or there could be a couple of serving layers, right? If you just one layer serving only the batch data and the other serving layer that is going to serve only the real-time data views, right? Or just have one server layer so that all the data could be available, whether if it's a batch, there could be a batch view. You can query the batch view for a batch data. You can query the real-time view for a real-time data, right? For the incremental or for the data that has been come in at the, just n-1 time, right? You just very recently that it has come, you want to query that data. So this is in short and in a very simplistic form what a Lambda architecture is. Now, if you just take this architecture, keep this in mind, go to and see how it could be simply done in AWS, right? So in AWS, you see all these different, you could be taking in, getting data from other databases or data sources. You could be, taking in a file. You just loaded a file in S3, right? And then you used, you used AWS Glue. You then put it in Athena and you queried data in Athena, right? What did you do really? It was almost like, building this batch layer here. So you did this batch layer, you had all the way up to here, you kind of build it in a very first assignment in AWS. The next assignment, you'll be building this kind of a layer here, almost very similar to what you see here, which is using AWS Kinesis to get in the stream data and see that it will simulate that stream data to kind of have that stream layer. So if if it is a very simple kind of a enterprise, you could have this simple view here put up here to kind of mimic a Lambda architecture. You could have data that could be coming in straight into a batch layer. You could be having some data going through a kinesis, or you could have one just kinesis going through all this there. And we'll talk about that. So hold on to that thought about having one single source, intermediate service to take in any kind of data. But here, as you see here, this is how simply a Lambda architecture could be created, and you've done half of this already. So that's what a Lambda architecture. Now, if you took it in a more general fashion, a Lambda architecture, you could have an HDFS. You learned about Hadoop. You have the HDFS as a batch layer, because Hadoop is all about batch processing. Hadoop is not stream processing, and HDFS is not meant for stream processing. It is meant for batch processing. So you have HDFS as in your batch layer. You have your Spark streaming for yours. You have Apache Spark for your streaming or your speed layer, and you have something like Kafka that could be bringing in, pulling in data and ingesting data from all different sources, so that you could let it pass through different sources. And you can have a serving layer where you have a data source, a data store like Cassandra and Hive, which you also learned about, and Hive sitting on it to kind of query your data. So this is simply how you can create a Lambda architecture. And these are the types of architectures that you will see in the enterprise world. Because in enterprise world, you cannot just stick with only and do with one single technology. You may be using multiple technologies, and that's where this is how different technologies are being used to do the kind of processing that you'll have to do for the type of use case you may have. Okay. So there are multiple companies, having the, this Lambda architecture, and very popular companies like Yahoo. It uses Apache Storm. It uses Storm for the, the real speed layer. It uses Hadoop for the batch layer. It uses Apache Druid, which is a, data store, which is a very, very enhanced data store used for, slicing and dicing. It's called used for very high speed data querying that you would need on your data, and any type of data or any amount of data. So that it's using these three different technologies to build the architecture. Netflix Sura projects uses a very similar architecture. It may not be exactly the Lambda architecture, but it is based on the Lambda architecture that it is using for its Sura project. And then LinkedIn is using this Lambda architecture and using this technology called Apache Calcite. So there are very popular companies and companies that deal with lots and lots of data that make use of the Lambda architecture. But again, it has its pros and cons, right? It has its advantages being the flexibility, right? You could have your batch data, you could have a real-time data, they're two separate layers. You have really you use the kind of a modular kind of approach to see that your batch data is going to be separate than your real-time data, which is fine. System can evolve very quickly because you made it kind of, you have what you call differentiated between the different types of data, and such systems can evolve very quickly. Scalability is not an issue, but it requires proactive management. Remember, data is coming at fast speeds and maybe at large amounts for batch processing, and maybe you're storing all of that data, which can grow exponentially over time. So you have to be very careful, because you are ingesting all that data that is coming to you and coming into this particular architecture. So it's not an issue, because you could have data stores at each of these different layers. You could have a master store to store that, and a batch store to kind of store some of the incremental data. You can do all of that. You can think of kind of trying to divide and conquer, but the main point is scalability, it can go for a toss, right? It requires some very proactive management. So comes to the cons of this is the maintenance of these two layers. Remember that when you have two different layers, and when you want to apply something to both these layers, you have to almost like saying you have to copy your effort, right? You have to duplicate your efforts. Whether it's programming something for one of the layers, you may have to take it over to the other layer. If you're doing some configuration setup to one layer, maybe that's also required in the other layer. So you are constantly doing that duplication of efforts, right? And maybe and also kind of managing that can become very difficult over time. It can become complex over time, right? And maybe it still does not overcome all the limitations due to CAP. Remember the CAP theorem, right? Consistency, availability, partition tolerance. So it is probably still not kind of going away with that kind of saying, oh, okay, Lambda architecture is the architecture. We don't have to worry, or it's the architecture. It takes care of CAP. It's pretty close to going to and having ACID properties, right? Maybe not, right? So there are still some issues with Lambda architecture, where now some of the companies have started to move towards Kappa architecture. And before I move to Kappa architecture, Alex, do you have any questions on the Lambda architecture?
I don't think so. I'm probably
Okay.
going to come up with a couple here soon.
Okay, very good. Alrighty. So let's move on to the Kappa architecture, right? We talked about the pros and cons of Lambda. So we had dual layers in there. Now, how about having a single layer, right? So this picture here of our Kappa architecture, and by the way, I've listed the sources, so you really don't have to take any notes or anything. I've listed the source, whether I'm using an image from somewhere or maybe a nice article. You have the source in there. You can click and read more to what we are talking, because we may not be able to do justice all within this short hour to kind of talk about everything about these architectures. But I want you to really go deeper into it, because there's a lot more to it, and some very, very interesting things about each of these architectures that I want you really to kind of read about as well. So once again, coming back to this picture, there's a single layer, right? So you see that a single layer with a master database, a master storage, and now it could have all this coming through one pipeline. It can serve to a real-time serving layer, or you can call it app, whatever it's called here. But you have it can have all the real-time data being served to the real-time serving layer. It could have the batch kind of a data serving to the batch layer. Each of them could have their own storage, which can hold only the incremental data, and then the actual main storage could have the entire universe, right? All that data that has come over, all that data that has changed, all of that could be stored and living here in one single storage. So once again, you could play with the little pieces there, but if you're using only one channel to get both your batch type or your real-time data, then that's kind of mimicking the Kappa architecture. That's what is called the Kappa architecture. Now, once again, if you're going to do this in AWS, you'll be doing something very similar. So what you're doing is you as I just mentioned, you kind of did something what is a batch layer. What you'll be doing next is kind of doing something which is going to be more like a stream layer or a speed layer, which is use of Amazon Kinesis to bring in the data into an Amazon EMR, which is you're already using it now as well, to process your data and then serving it to either an S3 bucket or to anything that you want to serve this to, right? After the data process, it depends on your use case, where you're going to serve your data, right? Or where it's going to be, what's going to be where the output should be going to. But the main point is that you are using a single source. You're using only Amazon Kinesis to bring in any kind of data. And this Kinesis is really a streaming kind of a service from AWS that you're using to bring in any kind of data. And it just sends it to Amazon EMR. So this is how simply you can create this particular architecture in AWS, okay? And some of the companies that are using this architecture, like Uber, right? it uses Kafka-based real-time infrastructure. Shopify, it uses Kafka, Flink, and data sinks for a blocks-based approach. Disney also uses Kafka cluster approach for a single source of truth. It has all the data that comes to it, it's stored within the Kafka cluster. And then this cluster actually serves to any department within Disney that needs data. It just goes to one single source of truth. How cool is that? Well, of course, there's definitely a lot of management, and there could be some disadvantages to that as well. But the thing is that they've kind of mastered this, right? They have got lots and lots of data like many other companies, but they've mastered this. Twitter has gone from a Lambda architecture to a Kappa architecture by using Google's cloud computing platform and GCP and along with Kafka. So Kafka is the key here within the Kappa architecture. As you can see, that was kind of a pretty much the theme, because Kafka is as you say, it's a pretty robust and a tool that's been very popular, and it's being used a lot for for lots of data ingestion, the data, how it brings the data in, how it stores the data, and all of that. So there's a lot of gains due to Kafka. So if you get a chance, do look into this particular tool, what Kafka is, or maybe you'll probably get to use it pretty soon. As I said, this is becoming very popular. It's already popular. I shouldn't not say becoming. It's already a very, very popular big data tool, one of the big data tools that is out in the market. Okay, so once again, like any other architecture, right? There's going to be some pros and cons. So single data processing engine, doesn't need any explanation here. System can evolve very quickly, of course, right? It's you made things more simple, so it can evolve as well at the same time. Scalability can only become an issue over time. Remember, you have a single channel to bring in all data. You have a single source of truth that the storage that you have probably depends whether you have it on the other, which is going to be used for incremental, or what kind of data that you store. But your scalability could become an issue because you're going to save everything. And maybe that is going to lead you to not be very flexible with the scalability of this kind of a system. Increased demand on the computational power, right? Everything is going through your real-time processing. Even the data that is really not needed real-time, you are treating them as being needed for real-time. So you are doing some heavy computation, maybe for no reason, right? Maybe for lots of data that has nothing, it's just really not needed at that. So there's some computational power that is being used, maybe there's some increased demand there. That's all I want to say. It maybe still be okay, but I'm just saying there's increased demand of computational power. There's increased demand of storage capacity too, which you may want to take and make a note of and take care of when you're using this Kappa architecture. Okay, so which one is better? Well, once again, as you kind of seen the theme, right? With any kind of such statements, it's better to say it depends on the use case. So here too, I would say that it has a lot to do with what kind of a use case you have. But you have companies that still love the Lambda approach, and they have still been using that approach. And I kind of went through those companies. You saw their companies, they're using Kappa. They were using Lambda, but they went to Kappa, and they're okay with that because they're dealing with both, because they don't have to worry about, maybe most of their data is already streaming data or real-time data, and maybe only some small percentage being batch data. So for them, it doesn't matter, right? The computational power was already there that they were using in the past. So there's not a big change in their computational resources that are being used. So once again, I would not say there's a single winner here, but you kind of saw what are the pros and cons, and maybe based on that, you may say, well, I'll go with a single channel, or maybe say, no, I will kind of keep things simpler, and I would keep 2 channels. It's fine, right? But just a thought, okay? So before I move on to the third one, the Delta architecture, any questions on the Kappa architecture, Alex?
Yeah, I just want to make sure I'm understanding this correctly. So Lambda versus Kappa, I suppose. as I understand it, it seems like Lambda requires a bit more in the realm of management. Like you need to spend a bit more time designing it, getting the architecture straight, and adapting it to whatever new data you may have. Kappa is a bit more adaptable. What Kappa requires more processing and more processing power and more data.
That's absolutely correct.
Okay.
So because the thing is, when you talk about Lambda architecture, yes, you have channels for bringing in your data, and you probably you know your data well, and you could say, well, I can have a same different channels, and I know which channel the data should go into, and I'm good with it. But when it comes to like kind of saying that I need to do this for both the channels, you will have to copy or duplicate the efforts across both the channels, right? Maybe there's a piece of code that needs to run on a script that needs to run for your batch processing. It also needs to run for your real-time processing. There's the structural change for data that you're bringing in the real-time mode, and also in the batch mode as well. You're making these changes both places, right? You have to keep up with that. So of course, there's some more management, there's some more resources that are kind of required for that, right? So, but once again, Kappa kind of solves that for you, but at a cost of more computational power, because now everything you're treating it as real time, right? So even though you may say, I really don't need to do anything on this day, but everything is you've used some very high computational power service for something that may not need that kind of a computational power, but you still use it, and that's fine. That's fine too, as long as you understand that that's what you're doing.
Okay, thank you.
Make sense?
Yep.
Okay. So then the next one is not really, I would say that it has emerged because of the limitations of the Lambda and Kappa architecture, but it's still a very good architecture that can also kind of kept in mind what Lambda is doing and what Kappa is doing, and how it is kind of some of the resources are based on being used for the storage of data. So Delta architecture came into being to make use of data lakes, right? And on the top of that, Apache Spark. And what that and it in this case, they call it as a Delta lake because data lakes by nature are immutable, meaning any change in the structure for anything in the data lake, you have to change all of the data that has come in, and it needs to, that's a wholesale change that needs to take place, right? For you, it may be like, okay, I'm changing this and go and change it, but internally, it's really taking in the whole, it has to really take out and copy the whole structure, make the change and copy the structure back and the data back in. So it's kind of an immutable from that perspective, and it's kind of taxing. It's also that the data lakes have an issue with between reads and writes, like where you could be reading some data while it's being written, right, where it's being updated, which may not be right. So there are some limitations and some issues of data lakes. Now, I'm not saying issues, but let's say limitations of data lakes that are now being, they got kind of being worked on by something called as Delta Lake. Delta Lake kind of, works on these limitations of data lakes and make it as a Delta Lake, and which makes things much more faster. It makes things, become more adhering to the ACID properties. So there you go. You're almost kind of making your Delta Lake, your data storage so efficient in a distributed environment that it is closely getting towards your ACID or towards ACID properties. It's kind of adhering to that. That makes it very powerful architecture by itself. Remember, you were struggling, in distributed processing, getting something to have the ACID properties is almost like a no-no. In fact, even with the CAP theorem, you saw that you could have 2 out of the 3, right? You could not have all 3 of them come into play for a distributed data processing system. But if some system is coming closer to doing that, and that's what Delta Lake is doing. Delta Lake is bringing that efficiency in your data, the quality of your data, the way you're going to be, reading and writing your data, and then add to that the processing power of Apache Stream. How cool is that, right? That's what the Delta architecture is doing. What the Delta architecture is also doing is something that is kind of, it may not be coming out clearly from this picture, but what it is doing is it also has the channels here, as you can see, but the channels are being used so that it can separate and it can only work on the incremental data. If there's a real-time data, let it go through, because the real-time data, as it should be read as is. If it is a batch data, let it store wherever it needs to store, both the batch and the real-time data, but only give the incremental data. Create a cube for that. In cube is nothing but an a view, basically a view that is going to be like a snapshot of your data, right? And which is going to be easier for you to do any kind of data analysis, right? So you are extracting the incremental portion of your data and showing it to the serving layer at all times. So Delta is all about kind of bringing that efficiency in your data lakes. If you're using a data lake, and in this case, it uses data lakes as a main infrastructure, main component here. It's bringing efficiency to your data lakes. It also bringing efficiency by looking at more at your incremental data, which is going to be of more value. At the same time, if it needs to be storing and using some of their old data for, let's say, for building your models, your predictive models, it is having the original data, and on top of that, you're adding incremental data to kind of keep updating your machine learning models at the same time. So that's why this Delta architecture is becoming very, very popular. And you'll see that there are companies out there that is using Delta architecture as well. Okay, so and there are some very processing platforms that are some popular platforms that you could see that. But before that, I want to kind of maybe I switch the slides a little bit. I have to put this front. But Delta architecture deployments, as I was saying, there are many companies that are already deploying this kind of architecture. Capital One, banking industry; United Health Group, health insurance; Costco, retail; GlaxoSmith Pharmaceutical, Ignify, software manufacturers. So many of these companies are also taking now advantage of these Delta Lakes and Delta architecture. And it's really, really working for them. And you saw that it's like an across all these different industries. It's not like a specific industry. So really making use of that. And besides that, if you really want to look at, what are the different data processing platforms across different popular cloud environments, then for AWS, you're already working with EMR. For GCP, you talked about Dataproc, your classmates talked about Dataproc. Azure, one of your classmates talked about HD Insight. And one of you also talked about IBM's Cloud Pak, which has got this analytics engine. So these are some very powerful platforms and powerful, cloud providers that have got this very powerful big data processing platforms. And I think making use of these is, if you can make use of EMR, if you're going to be successful using EMR, trust me, configuring and running Dataproc or HD Insight or Analytics Engine is not going to be a big deal. It's about what you want to do and how you want to get things done in an enterprise world is what is the important piece here. It's not about running this and spinning off an EMR or spinning off a Dataproc cluster or creating them. Piece of cake. It's not a big deal. But what you really need, what kind of configuration you really need, how are you going to make use of them, is going to be an important question to address. So I'm also leaving you with a link to it's a 5 minutes video that you want to look at, and it talks about all this top 10 big data frameworks in 2022, and it's a nice video. If you get a chance, take a look at it. It's a YouTube video, and I've cut it short to kind of 5 minutes for you. So hope you kind of enjoy that 5 minutes and understand some of those technologies that you may have also heard in today's webinar as well. Okay, so that, before I go into your assignment number 3 and talk about that in the next 10-15 minutes, any questions, Alex?
Yeah, I do have one. I was having trouble figuring out how to phrase this earlier, but I think I've got it now.
Okay.
I'm having difficulty understanding, especially for the Delta architecture,
Mm-hmm.
how processing upon incremental data works. So I'm guessing it's like you have 100 observations, you do something, I don't know, logistic regression, something simple like that, on all 100 observations. And instead of running it again when you have 105, you just analyze how each additional observation would change the values you get for the coefficients, for example.
That's right. That's right.
Okay.
So it's also like, like how frequently you're going to be doing that. So let's say you did it for 100 observations, and there's 100 observations went out, and you can say, okay, I'm going to wait for the other 100 observations to come through, and I'm going to use those incremental 100 observations to see how it changes my model or not, or let it just change my model, right? Let me take that 100 observations and put it on the top of the other 100 and make them and build my model again, or just build my model with those new 100 observations completely, right? So you can, depending on your use case, you can make a make a call there, or make a decision as to how you're going to you're going to change it and use it.
Okay, thank you.
Does that help, Alex?
Yeah, I think so.
Okay. All right. Okay. So any other questions, Alex?
Not at the moment.
Okay, excellent. All right, so we'll go to our next. Okay, so before I go on to our assignment 3, just some for food for thought, how would you take your learning about big data processing forward? What is your plan to practice the knowledge and skills you have learned? And think about, have you researched areas to find big data sets, databases that we talked about, and now we talked about some processing technologies, right? So think about how you're going to take this and start practicing on, all right? And of course, you're working in your AWS lab, you're going to be working on your assignments, but please start thinking about how you're going to take this forward, how you're going to probably just try this multiple times and make it second nature to AWS, and or take it to another cloud provider, or maybe to IBM, maybe to GCP, maybe to whatever, Azure, right? Or maybe just have your own different platform. That's fine too. But see how you can take this forward. And it's very important, because some of these things, they kind of, if they can only stick if you've been practicing it, if you're using it, and otherwise it kind of fades away very quickly. Okay, so keep that in mind. All right, so assignment 3, what are you going to be doing in assignment 3? Well, you're going to be using AWS EMR, you're going to be using AWS Glue, and you're going to use PySpark. So what's new in this assignment? Well, you know how to bring data into S3. You know how to use Glue now. You know how to use Athena, but in this case, we're not going to be using Athena. We're going to bring in PySpark Notebook on AWS EMR, right? Your processing engine there. So you're going to be using your processing engine, and then you're going to use the power of PySpark to really work on that data. It's the same data set that you've used in the past. So there's nothing different. So similar data set, but just try to use it in a different way. And that's what I'm trying to show it. And this is what you're going to be doing in this particular assignment. Now, as similar to the previous assignment, it also has a quiz. So whenever you go through your notebook and you're going through step by step, the assignment is going to tell you, the notebook is going to tell you, and you're going to be marking some of these, record, like the results from that notebook, right? Just mark it, right? And just make sure you understand. Just make sure you kind of copy that. You can also save it as a notebook with the result set as well, right? So you kind of learned about notebooks. This is a Jupyter notebook, so nothing that you would be it would be kind of brand new to you. So just make use of that and then address the quiz. So the purpose is to make use of the Spark framework in AWS EMR, it's called Elastic Map Reduce, and the power of PySpark to explore the same data set as I just mentioned. You will load the data into AWS S3 to use it as one of the most popular big data storage solutions, such as Data Lake, and then make use of AWS service such as Glue to apply structure to the data loaded, which you've already done in the past. And then you would explore and analyze or visualize the data using the PySpark code, which is in a Jupyter notebook, running on the Spark framework, which is provided by the EMR. Okay, so that's the main purpose. That's the main goal of this assignment. And if you look at the picture that is also part of your assignment, it's just exactly this. It's yes, I know it kind of looks simple, right? But this is exactly what you're doing. You're taking data in S3, you're processing using the processor, the EMR, and you have a Jupyter notebook that you're going to be running on the top of EMR using the Spark framework provided by EMR. And you've got the data already part of the Glue data catalog, right? It has already processed, it has gone through and structured your data, right? Provided schema to your data. So that's what it's kind of schematically what your assignment 3 is. Prerequisites, you're very much aware of all the prerequisites, right? Knowing you being part of AWS Academy, you've been part, you know that how to get into this. So, and I think you've already taken care of prerequisites here. And the only the prerequisite that you may have not gone through, which you may want us to go through to make sure you're ready for this assignment, is to complete all your reading material and videos on big data processing and AWS service and EMR. And if you get a chance, I will strongly recommend go through the optional reading this time, please. There's a lot of stuff that the only reason we did not make it as part of your classroom and make it mandatory here, because we know there's a lot that you guys have to go through and be prepared for this assignment. So we just have enough to let you kind of understand what this big data processing is and go through the assignment. But there's a lot that you could also do from an optional reading purposes. And yeah, and that's going to be also equally important. So if you get a chance, okay. Instructions, once again, very similar to the last assignment. So I'm not going to read through all of these and you know it all. The important part to remember is that the assignment has a quiz, and those answers you could get it from when you execute that Jupyter notebook. That's important piece to remember. And what is to be submitted there as well. Okay, your homework file, basically the assignment file. And the goal is to use the data that is by primarily using the same data that you used in the previous assignment, and then you explore it using your PySpark notebook. Some do's and don'ts that I also mentioned in my previous webinar about cleaning up of all AWS services. Please, you're going to be using a lot of services. You've been creating a cluster now, which is a heavy duty kind of a service. So please do not leave any of these services open and on and running, or even in your account. That could be taking in a lot of your credit that has been provided to you as a student. So please, ensure that you clean up your service, ensure that you're within your 4-hour window. If your 4-hour window is up, that's okay. You can everything will be saved as is, log out, come back in, restart the process. And remember that assignment 3 is not complete until your quiz is completed. Okay. Remember to capture your responses and your screenshots as and when required or needed. Okay. And lastly, this is the rubric that is also part of the description, and it gives you points for everything. As you can see here, you get a maximum points for your quiz because it's going to be capturing all the answers from whatever you'd be doing. Everything is going to be captured by a quiz itself, right? So, but once again, it has been going to be giving you points for the other things as well. So very important that you submit all your work along with the quiz. Okay, so with that, I know we're at the top of the hour and I want to make sure that we complete on time. But before that, very important, Alex, I'm ready to take in any other questions that you may have for me, or Yelena.
I don't think I have anything for assignment 3 of the architectures, but I do have a very brief question about next week's discussion post.
Okay.
And that is, it's ethics and machine learning, review the 6 ethical case studies. And in that sentence there, 6 ethical case studies, there's a hyperlink provided, but the hyperlink does not work. And I can't find the readings in the content. So I don't know if that's.
Okay, I'll take a look at that. Thank you for bringing it. So this is saying that in the classroom, when you have that discussion within discussion, it gives the links to all those different case studies. And
yeah, it says part 1, review the checklist, part 2, review the 5 Cs, and those links work. It's just the first one that doesn't. It says
the
some sort of
first one
typo.
doesn't work of all the others. Okay, got
yep.
you. I'll take a look at that. Thank you for bringing to my attention. Appreciate it.
Of course. Yeah, and I think that's it.
Okay.
Wish me luck with assignment 3, I guess.
Oh, it'll definitely. As I said, if you go through the steps, you'll find it an easy assignment. And the fact that you're building something very heavy duty, that's what I want you to guys, to get you and your classmates to appreciate it. That a lot of stuff that you're doing here is heavy duty and something that is also done at the enterprise level too. Yes, of course, there are all those configurations and things could be a little different there, and something that get added on, like from a process perspective, something like from a governance perspective, and all of that from security perspective, things get added on. But trust me, in a very simplistic way, what you're doing in your assignments is very, and you're going to tell me, like, once you start working out or are working in this space and working in this area, and you'll see that a lot of things that you learn here, you're going to be doing almost pretty much the same outside as well. Okay.
All right.
Already.
Well, practice makes perfect, I guess. So.
Yes, absolutely. Keep practicing and keep looking at all the other stuff that could be even outside the realm of this classroom. Like, as I said, go to Azure, go to GCP, go to IBM, look for what services they provide, practice things over there. That's going to be really helping you, and going to be prepared. Like, you'll be prepared to kind of say, okay, if you are going to plan to apply for a company that has been working with IBM, right? They don't work with AWS. So, but I think this is, if you know the concepts well, if you know a service or how things are done in one area, you can easily know what there could be something very similar in the other area. If data lakes are being done by this one company, how different could it be in other companies, right? So it's different name, different, sometimes little bit of a different architecture, but things are all kind of very similar, right? And so it becomes easier. So keep that in mind. Okay.
All right.
Any other questions?
I don't think so.
Okay. Yelena, do you have anything to add or any questions before we wrap? Before we call it a wrap, sorry.
No, I think you did a great job. I think
okay.
you did everything.
Okay, very good. All right. Thank you both. And thank you for attending. And we'll call it a wrap. Good night, Alex and Yelena. And we'll meet again in a couple of weeks. Okay.
All right. Good night. See you in a couple of weeks. Thank you.
Thank you. Bye-bye.